Hello. So we are again continuing on the circles chapter, looking at circles. And last time we looked at the equation of a circle again, which was x minus a squared plus y minus b squared equals r squared. Then we considered the circle, right, the centre at AB, radius r. And what we looked at last time is considering when any straight line intersects a circle. So you have two intersections like this, or it may have one intersection, which we call a tangent, which we'll be looking more at today around this section in this video, and even when it has no intersections. Okay, so that's sort of recapping. We will be using that as some examples today. However, I'll leave that there. What we're going to then look at is start to look more, I guess, geometrically again, and I do highly advise you look at the chapter 6.1, which I did, where we looked at midpoints and perpendicular bisectors, because one of the properties we will be looking at is called a chord property of a circle, which is exactly what we looked at last time. So as a reminder, for any given line, say points A and B, any straight line, we call the line that passes through the midpoint and it's perpendicular at that line, we call that the perpendicular bisector. Again, the name kind of gives it away. Perpendicular meaning it's perpendicular to the line, and bisector meaning it goes through the middle, so it has to split each line into equal halves, right? Anyway, so that's bisector. Why is that important again? So chords then, say in a circle, any line whatsoever inside a circle, any straight line, well, that's not that straight, that is a chord. As an example, this would be a chord. That is a chord. That's a chord, and I can keep going. Right. Any line inside a circle is called a chord. It is a chord. Okay. So it's just a fancy name for that, okay? A chord of a line in the circle. And in particular, you'll then remember very well the diameter as well. The diameter is a special chord that passes through the centre. And in particular, the diameter is the largest chord you can have in a circle. Okay. And it passes through the centre. Okay, cool. And the fact we will be using, which we used last time earlier on in the chapter, which we will be using again, and why we're talking about bisectors, is because if we have a chord, any chord whatsoever, again, the perpendicular bisector, if we draw it to the chord, will always pass through the centre. Okay. And then obviously what that means is if we continue the bisector through the whole circle, it must be a diameter. But anyway, we can then say that any perpendicular bisector of any chord, right? Of a chord, any chord, must pass through the centre of the circle. Okay. Cool. And we did look at examples like that last time, but we will be using that again today. But yeah, so that's the first circle theorem we will be using today. The second one is to do with tangents, okay, and this one you should be very familiar with GCSE, and the examples, the working we will be doing today will be like certain GCSE questions you would have seen, so it shouldn't be too unfamiliar. And the circle theorem related to tangents is, well, if we have a radius, obviously a line that goes from the centre to the edge of the circle, at that point on the centre, a tangent line, so remember that's when it'll a bit of a there we are, that's a bit of a nicer line. Obviously we call that the tangent, which is the line that passes that crosses the circle at that point on the edge. and you can use that also to estimate the gradient of the circle, the steepness of it at that point. But anyway, that's the tangent, where it intersects a circle at a single point. When the radius and the tangent meet, they meet at a right angle. Okay, so what that means is the radius and tangent of a circle are perpendicular. Okay. Oh, I can't. There we are. Perpendicular. And so yeah, that is what the two ideas we will be using in this section that you'll be expected to know for the exam. Okay, but this one hopefully shouldn't be too unfamiliar. This one perhaps might be less familiar, but we already did some work on it, but we will be recapping that. So yeah, and what the ideas that we've all studied will come into play because we might need to work out the equation, the equation of a circle. We might need to determine the radius and the centre in order to give us the idea of how to work out a gradient or something like that. Because if they're perpendicular, we will be needed to consider the gradients of the tangent and the radius. Okay, let's jump into some examples. So this example, first of all, example 10, we're given a circle C which has the equation x minus 2 squared and y minus 6 squared is 100. Verify that the point P lies on 10, 0 lies on C, so we have P, we have P equal to 10, 0. We also have the equation of the circle given to us here. Now what we need for part A is to simply show that 10, 0 indeed is on the circle. So we've got the equation there, so all we need to do is to substitute the point in. So I'm going to sub 10, 0 into the equation, right? The equation of the circle. So then x is 10, I get 10 take away 2 all squared, and then y is 0, take away 6 all squared. If I work that out in the calculator, I get, and hopefully I should get 100. So that's 8 squared and 6 squared. Yeah, that should work. I get 100, yes. So 100 equals 100. Yep, that's great. The news, it equals the right hand side, which means the equation is satisfied. So therefore, equation is satisfied. So 10, 0 is on the circle. Okay, and again, that's why it's handy to have the equation of the circle, which we worked out in the second part of this chapter, because then it allows you to work out points which you will need later on to work out more stuff. Anyway, so that's part A. Hopefully that makes sense. Part B then. Then it says, find an equation of the tangent to C at the point 10, 0. Give me an answer in the form ax plus by plus c equals 0. Now, there are two ways you can do this. Okay, so for part B, I do want to just jump in and interject. From editing, you could solve part B, because part B is talking about a tangent intersecting with a circle. So you might think, what if I do the substitution method, like we saw in the last video, where you equate the line and the circle together to find like a missing number. You could, because you could substitute 10, 0 into y is mx plus c to get this equation of the tangent, and then you could substitute that into the circle equation, and then you get then you do the normal process to find m, right? So then you consider the discriminant equal to 0, which there. So I've outlined the sort of method. However, you don't want to aim for that method at this time, but mainly because there's m's on both of these. You'll get an absolute nightmare if you try to use it using that method. Let me briefly show, because this is why I'm doing it in editing, to show how what you'd get if you did that method. Is it this one? Yes, it's that. That's let me There we are. You'd go through all of this, okay? It's absolute nightmare if you try to substitute, right, y is mx minus 10m into the equation of the circle there. You'd have to do so much, and you'd have to expand these brackets. It's absolute nightmare. Eventually you do get the right answer, so you can theoretically do it this way, but it takes so much time. And you're bound to make a mistake. There's so much algebra. I made a mistake like 2 times, I think, trying to do it, and then eventually you do get this, and that is the right solution, as you'll see in a minute. So I would advise, if you can't solve it any other way, then you do it, but otherwise try to avoid that method, and go through all that nasty algebra there. Duh, duh, duh. Yes, so then alternatively you'd look at a different method then, right, as I talked about. And actually, it turns out if we consider this, I'll go back into what I was talking. I'll go back to my video self in a minute when I'll go over it for the first time. Anyway, then want to solve it this way instead. So what you'd essentially do, and I'll go over it again in a second, is to consider the center. You'd consider the radius by the center to the point, and that allows you to find, because they're perpendicular, then you can consider gradients, and then that allows you to find m an easier way. So you'd opt for this method before you tried using any substitution algebra. If there's no other way you can make any progress, meaning if you can't easily work out the gradient of the line, or you can't find a point to do with the center or the tangent, then you'd opt for this substitution method. Otherwise, do try and do it using method 2, but that's my advice anyway. I'm then going to use is the circle theorem way, and then consider that if you have a generic circle here, a generic circle at the center there, and then obviously the tangent will be at this given point P. Oh, if I can draw it properly, P, which is 10, 0. Then if I then consider the radius, it will be perpendicular. Okay. So then, I then need to work out the equation of this line, this tangent here, using that information. Okay, well, again, the equation of a tangent needs to be in mx plus c form. Again, that's any line in general. To work out equation of any line, we can use this as our starting point. Okay, well, I need m and c, but another point, again, I could substitute that into the line to get the same thing as we did here, but I also need the gradient. Now, I know the line is the tangent is perpendicular to the radius, but I don't know the gradient of the radius either. Then what I do need to know is the gradient of the radius. Okay, well, I know the radius is at that point P, but it also goes through the centre, right? So then I can then work at the centre to work out the gradient between the centre and the point P, which then allows me to get somewhere. But I know how to find the equation of the centre because I'm given the equation of the circle. If I use the equation of the circle, then I know the centre is simply, if I read off it, well, if it's minus 2 for x here, it'd be plus 2 here. And then if it's minus 6 for y here, we did plus 6 there. Okay, and we also did loads of examples about finding the centre and the radius of a circle, given the equation again. But there we are. So actually we could fill in that the centre again is 2, 6. So I can add that to my diagram here. Again, I'm not worried about how accurately oriented my circle and how correctly positioned my points are. I'm just giving a rough sketch, right? But anyway, that's my centre. So now I've got 2 points. So then I can work out the gradient of radius. So I can call that m radius, say. Because now I know 2 points on the radius, C and P. Not C, looks like a C. No, it's just the center. It's 2, 6. It's a bracket, not a C. Anyway, I know the points 2, 6 and 10, 0 lie on the radius, so now I can find the gradient of it. So then I do change in y, change in x. So if I do change in y at p first, that'd be 0 for y. Take away 6 for y at the centre. Then for x, I do change in x, so 10 there. Then I do minus 2. That gets me minus 6 over 8. That goes to minus 3/4, I believe. Yes, cool. Okay, well then that's the equation of the gradients of the radius. Therefore, the gradient of the tangent, tangent I'm going to call it, well, that's the negative reciprocal because they're perpendicular. So negative of negative of 3 is going to be positive, and then if we then flip the fraction, so reciprocal will be 4/3. Okay, so that's my gradient. Okay, and again, once again, we can check this is right, as minus 3/4 times 4/3 indeed gets me minus 1. Remember, the two perpendicular gradients must multiply to get minus 1 every time. So we know that's right. Anyway, therefore, I can then start to fill in my equation of the circle of the line. The tangent should then be 4/3 x plus c, which is my gradient. Okay, but then I need a point to substitute in to find that c. But I know a point on the tangent, which is again p. So then I can sub 10, 0 into my line to then get y, which is well, y be 0, so then it'd be 0 equals 4/3 of 10 plus c. Therefore, c would be minus 4/3 of 10. That would be, if I put that, that'd be minus 4. Oh, that doesn't simplify. Oh well. Minus 40 over 3. There we are. But therefore, we've got our equation then. Therefore, y is equal to 4/3 minus 40 over 3. So there we are. So we've got the equation fairly quickly in that instance. So it is a better way if you consider it, and this is method 2, I should say. So yeah, we got. I think that work out to be quite quicker than using the sort of more routine algebraic method here that we looked at last time. You still can. It's fine either or, but I'll use that approach this time. But then we need to give our answer in this form here, so we need to rearrange it. So everything needs to equal 0. Okay, so we need to move everything to one side. So therefore, oh, that'd be 4/3 x there. I don't know why I missed out the x. So that'd be minus 4/3 x plus y, add 40 over 3 equals 0. And now technically this is in the form they wanted, but we can make all the integers coefficient by just scaling the equation. So let's times by both sides by 3, right, to get rid of the fractions. So then yeah, we times by 3 then to get minus 4x plus 3y plus 40 equals 0. Cool. There is our equation of the tangent. Great. Okay. Let's have a look at this example then. So we are told here that the circle C has equation x minus 5 squared and y plus 3 squared equals 10. And by the way, it's a good idea to kind of, as an autopilot thing, to just always immediately think of the circle and the radius. You can quickly spot that because they usually give the equation for a reason, right? And that you give them the equation because often they want you to work at the centre or the radius or both, right? But anyway. Let's just read the question. So we've got that equation of the circle. The line L is a tangent to the circle and has gradient minus 3. Find two possible equations for L. Okay. So again, well, I think in this particular case is a lot. I think it's a lot more effective to do the algebra method. I think it's a far more simpler method. So I'll demonstrate the other method that I talked about last time here. So we are told this circle's equation x minus 5 squared and y plus 3 squared equals 10. But then we are told we're given the line L is a tangent to the circle and has gradient -3. So that's y is -3x plus c. We're not told anything about c. We can't work out what c is because we don't know a point on that tangent. So there we are. But we're in good. We can still work out c because we are told it's a tangent, which means one intersection. And what does that mean? It means the discriminant indeed equals 0. So we can use the method we did last time of substituting. When they intersect, we can equate the two together. So we call this equation 1 and 2. We can substitute y here into y here to get a quadratic, right? Which then we can use a discriminant to then find values that we need. So that's what we're going to do then in this case. So then I'm going to say sub 2 into equation 1 to then get x minus 5 squared plus y, which should be minus 3x plus c plus 3 all squared equals 10. And then going to move the 10 to the other side to equal 0 to get an equation. Okay. So then I'll just need to expand these brackets. So I'll get x squared minus 5x minus 5x is minus 10x. And then minus 5 squared is plus 25. And then I need to expand this. So because that's quite a more complex bracket, I'll do it somewhere aside. So let's do it up here. So if I'm squaring it, I'm times it by itself. And that would get me, firstly, minus 3x by times and everything in the other bracket. Minus 3x times minus 3x is plus 9x squared. Then minus 3x times c is minus 3cx. Then I have minus 3x times positive 3 is minus 9x. Then for the next term c times minus 3x is again minus 3cx. Then I have c times c is plus c squared. Then I have c times 3, which is 3c. Then I move on to the last term. The 3 times minus 3x is minus 9x. Then 3 times c is simply, if it lets me, I need more space to the right. I might be able to squeeze it in. Anyway, then 3 times c is plus 3c. And then 3 times 3 is plus 9. I have to squeeze it in there. And then we can simplify it, so let's collect all the like terms. First is the x squared term, which was 9x squared. Then have collect the cx term, so minus 3cx, and then another minus 3cx is minus 6cx. And we can cancel as we go along if we want to. Then we have the x term, so I have minus 9x and another minus 9x. That'd be minus 18x. Then I have the c squared. Then I have 3c and another 3c is plus 6c. Then I have plus 9 at the end. Okay, so that's simplified. Cool, so then I'm going to substitute that back into here. So then I get plus 9x squared minus 6cx minus 18x plus c squared plus 6c plus 9. Then I have the minus 10 at the end equals 0. And then I'm going to collect the like terms again to then get x squared and 9x squared will be 10x squared. Cool. Then I have minus 10x minus 18x, that'd be minus 28x. Then I have a number, but I'm gonna collect the other terms first. Let's collect the cx terms right next. So minus 6cx. Okay. Then I have c squared. Okay. Then I have plus 6c there. Then I can add the remaining numbers together. Okay, 25 add 9 minus 10, that gets me plus 24 equals 0. And lastly, to actually get it in as a quadratic form, to make it clear, I can then group the x squareds, the x and the number terms together. So x squared is just 10x squared. Then for x, I then have minus 28 minus 6c. Then I just get the numbers at the end. C squared, 6c, and 24 equals 0. Okay, cool. Okay, well then now I at that point I'm in a position to use a discriminant, and because again it's a tangent, one intersection means one real root, which means it equals 0. Okay, remember when we did discriminants earlier on. Therefore then well, b squared would be minus 28 minus 6c all squared minus 4a of 10 c squared plus 6c plus 24 equals 0. Therefore, then we need to expand the brackets. So firstly, then minus 6, or we could rearrange that if we wanted to minus 6c and minus 28 if it makes it easier to visualise how it would expand. Anyway, we have minus 6c times minus 6c plus 36 c squared. Then we have minus 6c times minus 28 gets me plus 168c, and then that's another 168, so that would be plus 336c, and then minus 28 all squared gets me plus 784. Okay. Remember, if you that can be quite a tricky bracket to visualise if you're not if you're a bit worried about making a mistake or a bit unsure about certain algebra working. Remember to make you can do it aside with any bracket if you're really struggling, like this, and then expand it how you normally would, right? If you want to break it down to make it easier, and then there we are. But there we are, so that's that expanded. Then we do minus 4 times 10 is minus 40, and then we have the c squared plus 6c plus 24 all equals 0. Then we need to expand that, so we have 36c squared plus 336c plus 784. Then minus 40c squared, and then minus 40 times 6c gets me minus 240c. Then minus 40 times 24 gets me minus 960 equals 0. And again, now you can see it's a quadratic for c. So let's collect all the terms together. So 36c squared minus 40 is minus 4c squared. Cool. Then we have that's a c there. There we are. Then 336c and then minus 240c. That gets me 336 take away 240 is plus 96c. Cool. Then we lastly have 784 minus 960. That gets me minus 176 equals 0. And hopefully that should be able to simplify. Yes, I can divide f by minus 4 just to make it a bit easier to, I guess, read, I guess, if you want to solve it. But anyway, we get c squared minus 96 divided by minus 4 gets me plus minus 24c. Then we have minus 176 divided by minus 4 gets me plus 44 equals 0. Now it's a lot easier quadratic to solve, right? I might be able to factorise it, I'm not sure, but I'm just going to use the formula, right? So c then would be plus 24 plus or minus square root of minus 24. Oh, it's a bit messy, hang on. 24 plus or minus the square root of minus 24 all squared minus 4 lots of a is 1, c 44 over 2a, so 2 lots of 1, and that gets me that c could be and again, exam tip at this point, because I've shown my working, you don't have to write the whole the whole massive formula fraction. You can just jump into your equation solver in your on your class whiz or whatever calculator you use. But yeah, so that gets me c is 22, or c is 2, and that is actually a little bit of a sigh of relief because that's quite nice sensible numbers, right? So that leads me to believe I did something right. Anyway, so that's my two values then. There we are. So we found the missing ingredient, even though it took a bit of a while, but we then found the missing ingredient for this equation, the tangent there. So those are, we've got two values of c, which gives me two possible equations for L, the tangent, which therefore means the two equations, if you write them down, I don't know what's going on here. If we go back then, y is minus 3x plus c. So that means either y is minus 3x plus 22 or y is minus 3x plus 2. There we are. Those are my two equations. Okay, so this question then says the points P and Q lie on the circle with centre C, shown in the diagram. The point P has coordinates -7, -1, and the point Q has coordinates 3, 5, and they're drawn both of them here nicely for us. M is the midpoint of the line segment PQ. Big hint there, you're probably going to need to work out the midpoint. But anyway, the line L passes through the points M here and C, the centre there. So that hopefully you've recognised it's to do with perpendicular bisectors, as we have a chord, a line in the circle, and it's talking about a line through the midpoint going through the centre. That's going to be a bisector. But anyway, let's just deal with what the question's asking us. Then part A, it's asking us to find an equation for L. Okay. Yeah, so well, firstly, we know L passes through the midpoint, so we're going to need to work that out to have a point on the line. Well, the midpoint between P is -7, -1, and Q, which was here, which is 3, -5. The midpoint between P and Q, which is again there, well, we worked that out by just then adding the x coordinates first, so -7 add 3, all over 2 then, as there's 2 points. Then we add the y points, so -1 add -5 over 2. That will get me -7 add 3 is -4 over 2, that's -2. Then -1 -5 is -6 over 2, that's -3. Cool, so we have -2 -3 there. Looks a bit weird, I'll leave it there. So we've got our midpoint M, so that's point M. So we know a point that lies on the line, on this line here. Well, we even need another point, which actually we know it also goes through C. Again, that's this line here. It goes through C, but we don't know what C is. We're not given the equation of the circle. But what we should recognise is that L is going to be perpendicular to the line PQ. So this line PQ here is a chord, is a line in the circle. So the perpendicular, the bisector, the line going through the middle and going through the centre must be a bisector, perpendicular bisector, as every perpendicular bisector goes through the middle of a chord and through the centre. Okay, but that means we know it's perpendicular to the line PQ. We can work out the gradient of PQ. Again, to just do changing y, changing x. So firstly, let's take Q first. So changing y, so take -5, then take away the other y coordinate, take away -1. Then we do the same for changing x. So then we do 3, take away -7. Well, that's -5 and then +1, double negative. Same way, plus there. So -5 plus 1 is -4. Then 3 add 7 is 10, and that goes to -2 over 5. Cool. So that's our gradient of PQ. Therefore, therefore gradient of L, which is again the perpendicular bisector that we're working out, well, it's the negative reciprocal because it's perpendicular. So negative of -2/3 would be positive. Then if we take reciprocal 2/5, it'd be 5 over 2. There we are. And again, you can times them together and you should get -1. But there we are. If we've got the gradient, then we can then say y is 5 over 2x plus c. So we start to then complete our equation. Then we just need to find the c. So we need a point that we know on the line. Well, we know it's M, right? It passes through the midpoint, okay? So then I'm going to substitute the midpoint, which was -2 -3, into here. but then y is minus 3, and then 5 over 2x, where x is minus 2, plus c, therefore I can solve this for c. Then that's minus 3, well then 5 over 2 and minus 2, that's just minus 5 plus c. Therefore, if I add 5 to both sides, I get c positive 2. There we are. So therefore then, our equation is 5 over 2x plus 2. There we are. Cool. Part A. Then it says, given that the y coordinate of C is minus 8, find the x and show that the x coordinate of C is minus 4. Okay. So let's talk about the centre. So that means the centre has coordinate x, right? We don't know what x is. We need to show it's minus 4, but you can't just assume it's minus 4. We need to get there. But the y coordinate is minus 8. Okay. Okay, but we already know what the line. We already know the equation of the line now. Can't I then just substitute that point in to get the x? So then what I'm going to do then, because it lies on the bisector, the centre, I'm going to sub the point x minus 8 in into the equation we just worked out, because the centre lies on that bisector, it lies on the line. And I should get minus 4 for x. So then y is minus 8, then I got 5 over 2x plus 2. Then I get 5 over 2x. If I take away 2, I get minus 10. Therefore, x then is, if I divide both sides by 5 over 2, minus 10 divided by 5 over 2 gets me minus 4. Great stuff. Cool. Then part C. Find the equation of the circle. Well, that's fitting because now we found the whole centre point. Because we know what x is. X is minus 4. Therefore, the centre is x is minus 4 and y was minus 8. There we are. So then we can start to again fill in the equation of the circle. We know it's x minus 8. Well, if it's minus 4, it'd be plus 4 squared plus y minus b. Well, if it's minus 8 here, it'd be y plus 8 here. And that's equal to r squared again. Remember the equation of the circle, and you do need to remember it. It's this, right? Where positive AB is the centre, so we reversed like the signs in the equation. Okay, so then we just need to find the radius. Okay, we're not explicitly given the radius, but can we work it out? I think we can. Well, again, think about the radius. What's the radius? If I get rid of this to make it clearer, the radius is just from the centre to a point on the edge of the circle. We know both P and Q are on the edges of the circle. What if we then consider the distance between C and say, between point C, which was minus 4, minus 8, and this Q? The distance between those 2 points will get me the radius, right? So therefore, I'm going to say distance between distance between the centre, which is minus 4, minus 8, and point on the outside of the circle, which I'm going to just say let's use Q. That's 3 minus 5. Then how do I work out the distance between 2 points? I know how to do that. I did it in the last section when we looked at lines. We can work out the distance by doing like the Pythagoras distance between them. So that's going to equal then root of, well, the change in x. So that's minus 4, take away 3, all squared. Then the change in y. Minus 8, take away minus 5, all squared. Put that in order in the calculator. Minus 4, minus 3 all squared. Add, minus 8, then minus will turn to a plus. And that's a 5 there. So we minus 8 plus 5 all squared. That will get me roots 58. And that is my radius. Okay, well therefore if that's the radius, and radius squared, r squared, so therefore r squared is 58, right? It's root 58 times root 58, which is 58. Therefore, the equation overall then, if you substitute that in, we get x plus 4 squared plus y plus 8 squared equals r squared of 58. There we are. Cool. So we've got the equation of the circle, okay? And so, you might be freaked out if you saw a question like this mad diagram. But really break it down and do it part by part, and you realise it isn't that bad, right? If you just recall what you know, it really is a lot more simple once you break it down, and don't be freaked out by just looking at the overall question. Looks scary at first glance, this mad diagram, but break it down and it really isn't as bad. Okay, cool. So let's have a look at some exercise questions. So again, we're given a sort of diagram again, so let's do it part by part. So first we'll be given a circle C, which has this equation x squared and 18x add y squared minus 2y plus 29 equals 0. Then we need to verify that the point minus 7 minus 6 lies on C. But that just means I need to substitute minus 7 minus 6 into the equation, right? Into this equation there of the circle. And again, I don't need to make it fancy at the moment. I'm not asked to find any centres or radius. I just need to substitute it into the equation. So I don't need to do anything more. Just literally substitute x is minus 7, y is minus 6, and then I get, well, x squared with minus 7 squared, add 18x of minus 7, add y squared with minus 6 all squared, minus 2y, minus 2 lots of minus 6, plus 29, and hopefully I'll get 0 out of this, okay? So that will get me if I put that all in a calculator. Zero. Cool. So that means 0 equals 0. So both the right and the left hand side agree. They're the same. So therefore, equation is satisfied. Which means that the point minus 7 minus 6 lies on the circle. Cool. Okay, so then part B then. So that was fairly easy enough. Find an equation to the tangent at C at the circle at the point P, given ranks in the form was mx plus b. Okay. So I needed the equation of the tangent, which is here. Now again, if we're given the centre, we need to consider the radius, right? There. So the equation of the radius, we know is perpendicular to the tangent, so we will be using that. Now, we know what the point A is. The A is the centre, right? So A, we worked out what this... well, we don't know what the centre is actually, sorry. But we can work it out because we can get this equation of the circle into the form we're used to by completing the square. We looked at examples like that previously. So if I copy that down, I have x squared plus 18x. So take away y squared, take away 2y. Did I remember that? No, add y squared. Okay. Add y squared. Take away 2y. Add 29 equals 0. Well, to get it into the form of a standard form of a circle to find the centre, then I need to complete the squares on the x and the y parts. So then I get x, and then half of 18 is plus 9. All squared, take away 9 squared is 81. Then I complete the square on y, so y, and then a half of minus 2 is minus 1. All squared, take away 1 squared is 1. Add 29 equals 0. Then I get x plus 9 all squared plus y and minus 1 all squared. And then if I add the numbers together, I get minus 81 minus 1 add 29. That's minus 53 equals 0. But then I could just move that to the other side to get it equal to 53. Cool. Therefore then, the centre, I can read off to be, if it's plus 9 for x, it's minus 9. Then if it's minus 1 for y, it's plus 1 there. there we are. So we've got my centre, which is minus 1, 9. So that means this point A is minus 1, 9. So now I know 2 points from the centre. Well, no, 2 points on the radius, the radial line there. So I can work out the gradient, which then helps me because it's perpendicular, so I can work out the other gradient as well. So the gradient between the point A and P, again, A is the centre there, and P is the point on the line connecting to the radius. So that's going to be changing y, changing x between the 2 points. So P is minus 6 for y first. So minus 6, take away the other y value at A, it's take away 1. Then we do change in x, so we do minus 7 here from P. Then take away the x value at A is minus 9, so take away minus 9. That gets me minus 7, and then minus 7 add 9 is plus 2, and I think that's it, minus 7 over 2. I don't think you can simplify that any further. Nah. Yeah, that's right. I checked my answer. Okay, cool. So that's the gradient of the AP, which is the gradient of the radius. Therefore, if that's the gradient of the radius, the gradient of the tangent, sorry, the radius, yes. Therefore, the gradient of the tangent is the negative reciprocal. So negative on negative against positive, and then we do the reciprocal 7 over 2, it'd be 2/7. Therefore y, we can then say is 2/7 x plus c. Then to find c on the tangent, I need a point on the tangent. Well, I know p is on the tangent, so I'm going to substitute that in. So I get sub minus 7 minus 6 in. Into that equation, I then get y, which is minus 6, is equal to 2/7 x, so 2/7 of minus 7 plus c, which then gets me that's minus 6 is minus 2 plus c, if I work out that bracket, which then means c, if I add 2, is minus 4. Therefore, my equation overall is 2/7 x minus 4. Great. Oh, it asked me to rearrange it. Oh no, it's in this form, mx plus b. Okay. Sorry. Then it says, find the coordinates of r, the point of intersection of the tangent and the y-axis. Now the point r is actually there. Okay, so it's on the y-axis. So it's going to have, if it's on the y-axis, x is 0, and then we have a y coordinate there. Now again, that point r lies on the radius, a tangent we just worked out. We can substitute that point in 0y. So for the next part, part C, I'm going to sub 0y into the equation. So then y would equal 2/7 of 0 minus 4, which then means that therefore y is minus 4. So therefore the point R is coordinate x is 0, y is minus 4. Great stuff there. So we can change that as minus 4 there. Cool, then part D then lastly is saying find the area of triangle APR. I'm going to do that probably up here. So part D say do here. So again, if I draw the triangle APR on the diagram I have, so it's going to be A to P there, then P to R, then R back to A. So I get a triangle, okay, again. So then the area of a triangle is a half times base, B, times height, H. Now again, the base is going to be down here, right? What's the length, right? What's the distance between P and R? To find the base, well, we're going to need to use the distance formula probably, unless there's an easier way I can't spot, that I can't spot. So the distance from, so the distance PR, well that's going to be, then, I'm going to probably have to move this, right, the distance PR, so the area, again, is half times base times height, Well, the distance from P to R, which is the base B, that's well, R has coordinate. I should probably make a note of this. R is 0 minus 4. That worked out. P is given to be minus 7 minus 6, and A is minus 9 1. So then the distance PR, which is between these 2 points, I can then do change in x first. So 0 take away minus 7, which should be plus 7 all squared, and then add change in y. So then if I do minus 4 take away minus 6 all squared, I then get that to be, if I put that in the calculator, well, 7 squared, add minus 4 plus 6 all squared, gets me root 53. And okay, so that's the distance PR, so that's the base of root 53. So I could say that's a half times root 53. Okay, and so then we need the height. Well, actually, in this case, the height is actually the line AP, right? So if we were to that is the vertical perpendicular height, because if we were to reconstruct the triangle, say, it would look like that, and hopefully see that this side there, the height is the vertical height. So that distance then, well, actually between A and P, it's the radius, right? It's from the centre A to the outside the circle P, and we know the radius is root 53 because we worked out the area of the circle here, right? There, and radius squared was 53. That means the radius alone would be root 33. Okay, cool. But then therefore then, the height is root 53, so we get that. Therefore, it's 53 over 2 units squared for the area. Cool. Question 11 then. The circle C has equation x squared minus 4x plus y squared minus 6y 7. The line L with equation x minus 3y plus 17 intersects the circle at the points P and Q. First of all, find the coordinates of P and Q. Well, P and Q correspond to the intersection of the line. Not the greatest. The line here and the circle. We know what to do when the line and the circle intersect. We need to substitute them in. And actually we're given both equations, the equations of both the circle here, here, and the equation of the line here. But I could substitute one into the other to find the 2 points of intersection. So then if I rearrange the second equation in terms of y, then I get, well, in x, I think x is probably the best way, because x has no coefficient. I don't need to divide by anything. Then x is 3y minus 17. Then I'm going to substitute x here into the first equation. To then get x squared would be 3y minus 17 all squared, minus 4 of x, which should be 3y take away 17, add y squared, take away 6y, minus 7 equals 0. Then I just need to expand these brackets to then get, well, 3y also would be 9y squared. Then 3y times minus 17 is minus 51, and then another minus 51 will be minus 102y by expanding. Then I then get minus 17 all squared, gets me positive 289. Then I'll take away, then I expand this, well that's a lot simpler. So I just times everything by minus 4, so minus 4 times 3y is minus 12y. Then minus 4 times minus 17 gets me plus 68. And then we have y squared, take away 6y minus 7 equals 0. And then I can simplify this whole thing, bring all the y squareds together to get 10y squared. Cancel that out then. Then I'm going to bring the y terms together, so minus 102y, take away 12y, take away 6y, minus 102, take away 12, take away 6, gets me minus 120y. Then I can cancel those out. then I can just add the numbers together. So I get 289, add 68, minus 7 to get plus 350 equals 0. And if we want to, I can then simplify it down, scale it by divide by 10 to get y squared, take away 12y plus 35 equals 0. Cool, then I can solve this quadratic to then get y would be plus 12 plus or minus the square root of minus 12 all squared minus 4 lots of 1 plus 35 over 2a, so that's 2 lots of 1, and that gets me, if I put that in the calculator, y is 1 minus 12 plus 35, I get y 7 or y is 5. Okay, fairly nice numbers. Cool. Well, those are my two y values then. If I solve those are my two y values if I solve that equation. So then the values of x then, well, I know x is this, so I can substitute those two values to get the other values of x. So x again is 3y minus 17. Therefore, if y is 7, x would be 3 lots of 7, take away 17. That would get me 24, right? Yes. Always double check, even stuff like this. Anyway, then we have y is 5, then x would be 3 lots of 5 plus minus 17. I believe that should be minus 2. Yep, there we are. So therefore our 2 points are x is 4, y is 7, and then when x is minus 2, y is 5. So those are my 2 points. However, we need to then specify in this case which one's P or Q. We can do that because we've got the graph. So we know P is a negative x, it's on the negative x-axis there. Q is on the positive x-axis. So that means P is negative x. Well, the negative x coordinates this, so that's going to equal P. And likewise then this is going to have to be Q. And that's positive x. Cool. So then, therefore, we found the 2 points of intersection. Cool, let's have a look at the rest of the question. Then it says, find the equation of the tangent at the point P and the point Q. So, again, if we have a tangent there, and a tangent, or if we could draw it there somewhere, right? Okay, so I need to find both of those lines. So, I know P. I know that point P and Q now. That's what I've worked out. I don't know the centre though. I'm going to need again to consider the radius of both points, which are going to be perpendicular to both tangents. However, I need to know the centre to work out the gradient of the radius, to work out the centre of the circle to find the gradient of the radius. Okay, but I know how to work that out again. I know I'll probably do that up here actually. I can complete the square on this to then find the centre. So then I do x, and then half of minus 4 is minus 2, all squared, take away 2 squared is minus 4. Then y, and then a half of minus 6 is minus 3, all squared, and take away 3 squared is minus 9, and that's equal to 7. Then I do x minus 2 all squared, plus y and minus 3 all squared, and then if I add the number minus 4 and minus 9 is minus 13. Then I'm going to need to move that to get 7, add 13 to get 20. Therefore the centre in this case, well, if it's minus 2 here, it's going to be plus 2 here. Then if it's minus 3 in the formula here, it's going to be plus 3 here for the centre. There we are, cool. So now we know this point's 2, 3. And then we can go cracking to find the gradient, right? Okay, so if we commence with this, well, the gradient of the where should I do it? I'll do it down here. So we know the center's 2, 3. I'll make a note of that. Then I'm going to do it, I'm going to probably split this in half, right? Because I need to find the gradient of the tangent at Q and P separately. So if I then first do Q on the left side, firstly the gradient between the center, I'm going to call C and Q. That's then going to be changing Y, changing X. So Y at the center is 3. Take away the Y at Q7. Then changing X, I'm going to do 2, take away 4. So 3 minus 7 is then minus 4. Over 2 minus 4 is minus 2. That'd be positive 2 there. Therefore, the gradient of the tangent is the negative reciprocal because they're perpendicular. So negative of 1 over 2. Reciprocal 2 is 1 over 2. There we are. Therefore, we can say y is minus a half x plus c. But then we need to find the point on the tangent at Q here. So I'm working out this tangent here on the right. Well, we need a point on the tangent, but we know Q is on the tangent, right? Therefore, if I substitute the point Q in, so Q is 4, 7, I then get, well, y would be 7. So then 7 would be minus a half x of 4 plus c. And then 7 is minus a half times 4 is minus 2 plus c. Therefore, c is equal to 9. So therefore, y is minus a half x plus 9. So that's the gradient at tangent at Q. Cool. So then I'm going to do the same for the tangent at P because I need to find that as well. So it's the exact same process, right? Then I need to find the gradient at P to Q, P to the center, sorry. So now I'm, what is that? P to C. So that's going to be, so now I'm going to be focusing on that equation then at P. So then the gradient from P to C, so then the radius, the gradient of the radius here from P to the center C is going to be again changing y, changing x. I've noted the coordinates here again. So if I start from P, so y is 5 here, take away the y coordinates at the center is 3. Then we do change in x, so minus 2 here, take away 2 there. 5 minus 3 is 2, minus 2 minus 2 is minus 4, so I get minus a half, as that simplifies 2. Therefore then, the gradient of the tangent in that case, again, is going to be the negative reciprocal, so negative of negative is positive. Then we do the flip 1 over 2, we get positive 2. There we are. Therefore, we can say that y then is 2x plus d. I'm going to use a different letter to c for the equation of the tangent. Again, then to find that missing number d, I then need to sub a point in that I know is on the tangent here. But again, the point P, which is where the tangent is at, that is on the line, so I can substitute that in. So P is minus 2, 5. So I can substitute that into here. And so therefore, well, y is 5. 2x, x is 2, minus 2 plus d. Therefore, 5 is minus 4 plus d. So therefore, d would be plus 9 if I add 4 to both sides. Therefore, we've got the equation of y is 2x plus 9. And that's tangent at P. Cool. There we are. So then part C here. Find the equation of the perpendicular bisector of the chord PQ. So again, if I get rid of this now, these radius I've drawn in, the bisector is going to pass through the middle M, and it's going to go through the center, right? Remember, that's a fact we discussed earlier. So then we need to find the midpoint of PQ, first of all, to find a point on this bisector. Oh, to find the midpoint as it passes through the midpoint. But actually, no, we don't. Why do we not need to find the midpoint in this case? Because we already know what the centre is. We have a point already on the bisector, and we can work out the gradient between P and Q. So actually, we don't need to do that extra work. So what we can do instead is find the gradient of PQ, the line PQ, and then it's perpendicular. So then we can do the negative reciprocal. So then we can then say M of between P and Q, the gradient P and Q. Well, P is -2.5, Q is 4.7. So therefore, the gradient between P and Q, the change in y, change in x. Well, it's going to be 5 for P. Take away, I'm going to write these points down again. I don't want to keep referencing it. P is, what was it? -2.5. And Q was 4.7. Okay. Therefore, the gradient then, if we take P, y, and then take away the y value at Q, would be 7. Then we do change in x, so then -2 for P. Take away 4, that gets me 5 minus 7 is -2. And then -2 minus 4 is -6, so that'd be plus a third. Okay. Therefore, then the gradient of perpendicular bisector, that's going to be in the negative reciprocal again. So negative, if we flip a third, we get 3/1, which is 3. So we get -3. Therefore, then we can start to get the equation of the bisector to look like y is -3x. Then I'm going to use a different letter, k. Okay, again to distinguish between C and D up here, because it's a different line, so I have a different y-intercept. Anyway, then I can find the point here, because I know a point on the bisector to find that missing value k. If it lets me scroll up, there we are. The point, the centre goes through the bisector, right? That's what every bisector does, it goes through the centre. So we know the centre is 2, 3. We worked that out up here. So we can substitute that point in. So we don't need to find the midpoint in this case. We already know a point to sub in. If we do that then, well, y is 3. And then -3x, so x is 2 plus k. So then 3 is -6 at k. Therefore k is, if we add 3 we get 9 again. Which means our equation is y is -3x plus 9. Cool. There we are then. So that's the equation of the bisector. Then it says for part D, oh God, 13 marks worth this as well. Show that the two tangents, which we worked out, tangent here and the tangent there, and the perpendicular bisector all intersect at a single point and find that coordinate. Okay, well, they're all intersect. If we continue, we can see this, because if we then continued on the lines, here, there, and there, well, I mean, that's a bit off. Let me draw it a bit better than that. You can see they all intersect up here somewhere. There we are. They're all intersect at this point, probably, right? Visually, we can see that. But we need to show that. So we need to equate all three lines together. Well, it's a good thing we know all the three line equations already, which makes it very easy to substitute it in. So I'm going to say, firstly, y is, let's equate the two the two tangent equations together. So the tangent at Q is this, and the tangent at P is this. So let's substitute that in. So y is -1/2x and plus, what was it, plus 9. And y is 2x plus 9. Okay, if I do that then, if I substitute that in, therefore equate them together, I get 2x plus 9 equals minus a half x, and it's part D, minus a half x plus 9. If I add a half x to both sides, 2 plus a half is 5 over 2. So that's 5 over 2x. Then I'm going to move the positive 9 to the other side. That would get me 0, okay? Therefore, x is 0. So therefore, then y is minus, well, 2x plus 9. Say, substitute the x value into either equation to get y. I'm going to substitute it into that one to get 2 of 0 plus 9. That gets me 9, okay? So therefore, the point of intersection is equal to 0, 9. However, that's the intersection between the two tangents. What I then also need to show is that also the bisector crosses at that same point, as we can see in the diagram here, right? The bisector and the two tangents all intersect. That's what we need to show. Right, find the intersection point. To verify that the bisector also crosses with that point, well, I'll have the bisector equation here, right? So I can use that to substitute that point in, and it should be true. The equation should be satisfied. So then sub 0, 9 into then y is equal to minus 3x plus 9. I then get that, well, 9 is y, minus 3x and minus 0, add 9. Right, indeed, 9 equals 9, okay? Therefore, the equation is satisfied. So, point also lies on the perpendicular bisector. And I'm going to say as well as the two tangents, okay? Because we know it already is on the two tangents, and we know that point is also on the two tangents, because when we equate these two lines together, which are the two tangent equations, that point of intersection we found is the point of intersection between those two tangents. So then we just need to check that it also is on the bisector line, which we just done here. So therefore, there we are. Okay, that's our question dealt with. So they've got this question here then. So again, hopefully you see that them sort of geometric questions look scary if you just look at the diagram and there's just a bunch of words and these equations, but they're really not. Once you go through it bit by bit and you work out what you know and to apply, it isn't too bad. Let's have a look at this one. It also looks a bit scary. So we're given a circle C which has the equation x minus 6 squared add y minus 5 squared is 17. The lines L1 and L2 are each a tangent to the circle and intersect at the point 0, 12. Find the two equations. So this is very, very, very reminiscent to the example we did. If I can find it. No, it's one of the examples we did earlier. Very, very similar. So what we did was, and what we're going to do here is, we got two lines that are a tangent, and we know they both pass through the point 0, 12. So, okay. So we know the equation of any line is mx plus c. What I'm going to do is substitute this point in, okay? To 0, 12. So then y be 12, m of 0 for x plus c. Therefore, c is 12. And we can see that there, right? The y-intercept is 12. That means both the equations have to be in the form y is mx plus 12. Now, obviously, the gradients will be different. But what that means is that really, that's the equation of the line, and we are intersecting it with the circle. I got the equation of the circle. So if I then write down the equation of the circle, x minus 6, sorry, not 3, all squared, plus y take away 5 all squared equals 17. Well, the tangent intersecting with the line, the tangent, I can then equate them together, right? And the thing is, these are tangents, so there's one intersection again, which means one real solution, which therefore means the discriminant equals 0. So that tells me I can use a discriminant to work out this m, the values of m. Okay, and so we can proceed. So let's substitute equation the y, so the first one into the second equation. So y is mx plus 12, so then we have x minus 6 all squared, add y, which would then be mx, plus 12, take away 5. Now we can simplify that down, that's just 7, okay? All squared, and then we can move to 17 equal to 0, and then it's just another bog standard sort of circle substitution question, which we looked at last time and earlier. So we expand the brackets to get x squared, then minus 6x minus 6x minus 12x, minus 6 all squared is plus 36. Then we can expand this bracket. Now I'm not going to do, this is a nicer one because it's only 2 terms. I can do that in my head, but again, if you're a bit uncomfortable or whatever, you can do it manually somewhere on the page, right, and expand it one by one. But here, if you do that expansion, you get m squared x squared, mx times mx is m squared x squared, then mx times 7 is 7mx, another one be plus 14mx, then 7 squared is plus 49, minus 17 equals 0. Then I'm going to do the same sort of thing of collecting the x squared terms. So x squared, but actually got 2 x squared terms. I have an x squared of 1 and then an m squared. So that'd be 1 add m squared x squared. Then I'll collect the x terms, so I can cancel those out. Then I got minus 12x plus 14mx, that's minus 12 plus 14m. Then I can add the numbers, so 36 add 49. Take away 17, that gets me plus 68 equals 0. And now I've got a quadratic in x, and then I can use the discriminant, right? So because it's a tangent we're dealing with, that means there's only one intersection with the circle, which means the discriminant's equal to 0, because there's one real root, one distinct real root. Therefore, if we do that, well, b squared is this coefficient here of 14m take away 12 all squared, then take away 4 lots of a, which is actually this bit, 1 plus m squared, of c, which is 68, and that's equal to 0. So then I need to expand these brackets. So firstly, 14m times 14m would be, well, what's 14 squared? 196m squared. Then 14m times minus 12 gets me minus 168m, so that's another minus 168, so that would be minus 336. Then minus 12 times minus 12 is plus 144. Then I need to expand the right set of brackets. So firstly minus 4, then I'm times it by the 68, so then 68 times minus 4 gets me minus 272 of 1 plus m squared, and that's again equal to 0. So then if I expand that bracket, I get 196m squared, take away 336m plus 144, take away 272, take away 272m squared, equal to 0. Then again, this is a quadratic for m now, which is great because I'll be expecting 2 values because we have 2 tangents, so that's great. So if I collect the m squared terms, well, 196m squared, here, take away 272, m squared, I get minus 76, m squared, I can then cancel that out. Then I got minus 336, and then add 144, take away 272, I get take away 128, equal to 0. I don't imagine that's, it might simplify, but it's not a nice simplification. Okay, so that's the quadratic we get. And then everything's negative, so I will flip all the signs by dividing both sides by minus 1 to get 76m squared plus 336m plus 128 equal to 0. Therefore, then, if we use the formula, we get m is minus 336 plus or minus the square root of b squared 336 all squared, take away 4 of a 76 128 all over 2 times a 2 times 76, and that gets me put that in the calculator, 76 okay, m is minus 8 over 19, or m is minus 4. So again, fairly nice values. So again, I guess as the exam tip, that kind of suggests you're in the right path. Okay, so that's number 2m, but those correspond, remember then, to our, well, it corresponds to this, right? The equation of the tangent. But obviously there's two tangents, so there'd be two different gradients, right? But we got the two gradients, right? It's minus 8 over 19 and minus 4. So therefore, because we know what c is, it was 12. Remember, we got this equation of the tangent. If y is mx plus 12, therefore the two tangents, because we've got two different values of m, the gradients, they are y is minus 8 over 19ths x plus 12, and y is minus 4x plus 12. There we are. Cool. Okay, so let's move on to some exam questions. So we are given this graph here, figure 3. It shows a circle with that equation and the line with this equation there. So we've got we've got these two equations. We need to then first find for part A, sorry, the coordinates of the centre of C and the radius. So that's a bog standard sort of question, right? You've got the equation of a circle. You need to find its centre and its radius. Okay. Okay, so again, firstly, it's best to group the x terms together. So x squared minus 10x plus y squared minus 8y plus 32 equals 0, as then we'll be completing the square on the x and the y parts. So then for x minus a half of minus 10 is minus 5 all squared. Take away 5 squared 25, then add y, and then half of minus 8 is minus 4 squared. Minus 16 plus 32 equals 0. Then if we group get the brackets first, as so, then we add the numbers, so we get minus 25 at minus 16 add 32, that gets me minus 9 equals 0, but then I could just move it to the other side to get equals to positive 9, and there we are. From this then we can therefore deduce that the centre, well, if it's minus 5 for x, it'd be plus 5 here, and then minus 4 for y would be plus 4. And the radius, well, radius squared would be 9, so the radius alone would be root 9, which is 3. Cool. Okay, then part B, the interesting part, it says find the shortest distance between the C, the circle, and the line L. Okay, so we haven't explicitly done a scenario like that. So what that means is the shortest distance, so obviously the distance between the line and the circle, we want the shortest distance, so that's going to coincide with, well, it's going to be roughly that point there, and it's going to be roughly that point there. That's going to give us the shortest distance, right? There. Now what's interesting is always the shortest distance between a line and a point. You would have done this at Cheese C, I think, very briefly. So obviously, I don't think many people would recall. But between a line and a point, the shortest distance between them is what we call the perpendicular distance. So it's the line that's perpendicular to the line, connecting the 2 points. Okay, as so. So that will be the perpendicular distance. As for y, I guess very briefly, although this doesn't come up often at all, so this is just for this question. But if we had, say, if we kept this perpendicular line, say, but I didn't know it was the shortest distance, if we then, say, assumed it was like another, say, if we draw another line now and we suppose that was the shortest distance instead, well, actually, that would then be the hypotenuse, right? Because we have a right angle that doesn't look it. Okay, well, let's say we have this instead, right? That line. Well, that line's going to be hypotenuse, and we know the hypotenuse will always be the biggest side, but we want the smallest side, right? So it turns out whatever else at this point, we know it's going to be roughly that point. We don't know what that point is exactly. We don't need to know, but we know it's going to be a point on the line. That has to be the shortest distance. Anyway, if we draw any other line at that point, that would be a hypotenuse because we have a right angled triangle because of that side. That would mean that any side we create other than this one, the perpendicular length side, would always be bigger than this side. So the shortest line between the two points of interest is in fact a perpendicular line here. Okay. So yeah, we're interested in the distance here of this line. And again, it's very reminiscent then to perpendicular bisector, isn't it? And in fact, this is a perpendicular bisector because, well, actually, if we were to then move this line, say to be, it can then be a tangent at this point. It'd be the same line. But then if we continued it, this line, that other line we draw, that's then also perpendicular, as it's just the same lines. But then it would then be a perpendicular bisector, right? No, sorry, it'd be a radius. Sorry, my apologies. It'd be a radius, but we know a radius because because that's a tangent and the radius is perpendicular. But obviously the radius goes through the centre. So what that means is, and you probably could have spotted that perhaps by just looking at the graph if you extended the line. What that eventually means is this sort of, not perpendicular bisect, but it looks it, right? But this perpendicular line, which contains, and I want this distance here, that distance D there, that's what I want. But I know that if we were to create a line, right, that line would also pass through the centre point there. Okay, so what's my strategy then with that in mind? Well, I know the centre, they asked me that for a reason. That's 5, 4. And also the radius might come in handy as well. But yeah, because the radius will be 3. Remember, in these sort of geometric problems, it's always helpful to consider the radius at some point. So the distance between the centre to the circle will be 3. Okay. Okay, but I also note it's a perpendicular, right? But I know the equation of the line, right? I can then work out the gradient of the line L here, and then almost like a perpendicular bisector, right, we can then compute the gradient of the perpendicular, right? So then 2y plus x plus 6 is equal to 0. If I rearrange it to y is mx plus c to get the gradient m, that would be 2y is minus x minus 6. Therefore, Therefore, y will be minus a half x minus 3. Therefore, the gradient of L, I'll call, no, I'll just say, if my laptop lets me, the gradient of L, which is the line drawn for us, that's going to be minus a half then. Therefore, the gradient of the perpendicular is perpendicular, so it's going to be negative reciprocal. So negative over negative would be positive, and then 1 over 2, the reciprocal, flip that, be 2 over 1 to be just 2. Okay, cool. So actually then what I'm going to then start to do is find the equation of that perpendicular line that I've drawn there, right? Why am I going to do that? Because if I then find the equation of that line, I can then find that point here. I'm going to call that point P. So I can find that point actually. And then why is that useful? Well, I can then find the distance between P and the centre. Because I know the distance between 2 points, and that will allow me to find the distance that I want overall. Okay, so that's my plan of action. So then I need to, well then the grade of the norm, well the equation of the normal, I can then say y is 2x plus c, but then I need a point on it. But I know that perpendicular line then goes, it then would also go through the centre of the circle, because it would end up being a, it would then be on the radius as well, so it would pass through the centre there. So that would be 5, 4 on that line as well. So so if I substitute 5, 4 in, well, 4 be y, 2x, 2 lots of 5 plus c. Therefore c, that'd be 2 times 10, 4 take away 10 being minus 6. There we are. So now we've got our equation, right? Cool. So that means therefore that y is 2x minus 6. Okay. Okay, well then that's the equation of the perpendicular, but I also know the equation of here. I know the equation of the line L. So I can find that point P, which is again over here, the intersection between that perpendicular and the line, okay? Which will then allow me to consider some distances between points. Anyway, so then that be also equated because they're intersecting with the line. I could substitute the circled equation, but I rearranged it quite nicely to y was minus a half x minus 3 here, right? So I could just substitute that in. So y is minus a half x minus 3, because I'll have to rearrange it anyway if I use the other form. Anyway, so then we'll substitute equate them together because they are equal, because they're intersecting. I'd have minus a half x minus 3 is equal to 2x minus 6. Then if I add half x, I'll get minus 3 equals 5 over 2x. 2 add a half is 5 over 2 minus 6. If I then add 6 to both sides, I get plus 3. Then I get that x, and if I divide by 5 over 2, 3 divided by 5 over 2 gets me 6 over 5. So that's my x point. Therefore then y, well I could substitute that into either equation. Actually no, I'm going to substitute it into here. It looks a bit nicer just because there's no fraction. Anyway, so then y would be 2x minus 6, that'd be 6 over 5 minus 6. Then the y value, the corresponding y value, would get me, if I put that in a calculator, say, that would be minus 18 over 5. Cool, so therefore the P, the point of intersection between the two lines, was 6 over 5 for x and minus 18 over 5 for y. Okay. So that's, if I write that here, what was it? 6. I know the y value is minus 18 over 5. God, I forgot it already. 6 over 5. Okay. There we are. So that's my point. Now, I can then, well, what I'm working out then, if I then do it here, I want to work out the point P and this point there when it meets the circle. But that line also then goes on to meet the centre C, which is 5, 4. And P again was 6 over 5. 6 over 5 minus 18 over 5. But I want to work out, if we look at the let me get rid of some of the annotations to make it, because the diagram's a bit messy. There we are. But I want to work out that length there. That's the distance between the line and the circle. So I want to work out that distance there. Okay, but then I know that this is the radius, right? From the center to the circle edge. But I can also work out the overall distance because I know the 2 points. That'll be the distance formula, right? So then I can say that that's the root of changing x. Laptop freeze. I've written too much. That's why. We're nearly there though. So we then do change in x between c and p, the 2 points. Let's do 5 take away 6 over 5 all squared. Then the change in y. So then 4 take away, minus 18 over 5 plus 18 over 5. And then that distance will be between c and p. So that would be the length PC, which is the length. If I put that root in the calculator, 4 take away 6 over 5 all squared. Gets me 19 root 5 over 5. Okay, so the overall distance here between P and C, the center of the circle, so then the distance from the line P to the edge of the circle, D, is going to be the overall distance 19 root 5 over 5, take away the radius 3. And I'll put that in a calculator. If it simplifies, it doesn't get me anything nice really. But it just gets me this number fraction here at minus 15 plus 19 root 5 over 5. Okay, which I guess you could say is 5 points. Sorry, 5 to 2 dp decimal places if I've rounded it. So yeah, there we are. So it's quite a part B. Yeah, part B is quite weird. But in general, if it ever comes that you need to know the shortest distance between like 2 points or whatever is going to be the perpendicular line between them. Okay, it's going to be a perpendicular line. But other than that, it's very reminiscent to the other examples we just did while considering the rectangent, the radius and all that sort of stuff. Okay, and again with these sort of distance questions like here, you should always consider the radius. That will help you out. But yeah, the final question then I will look at. So we're given a sketch again of a circle with centre N, which was actually given to be 7, 4. Okay, the line L with equation y is third x. We're given that as well, quite nicely, and it's a tangent to to C at P. And it says find the equation of the line PN, so it's going to be there, and it's going to be a radius, right? And it's a tangent, so it's going to be perpendicular. And so we can use that to find the equation of the that radius Pn. So we already know that the gradient of the tangent, because it was a third x, the gradient would be a third. Therefore, gradient of the radius, or Pn, well, it's going to be the negative reciprocal because they're perpendicular. So it's going to be negative 1 over 3 will be 3, so minus 3. There we are. So then y is minus 3x plus c. Then we just need to find that C. We need a point to substitute into our radius here, but we know the centre also lies in it. So 7, 4 is the centre. I'm going to sub that in. So sub 7, 4, and then y before equals minus 3x, which should be 7 plus C. Therefore 4 is minus 21, add C. That means that C, if I add 21, is 25. Cool, so that as a whole, y is minus 3x plus 25. And there we are, it's in the form that they wanted. Cool. Then for part B, there then says find an equation for C. Okay, so for the circle. Well, actually, we've already given the centre, so we can start to complete our equation already. So if the centre at x is 7, then it's going to be x minus 7 in the equation, and then for y is 4, then it's going to be minus 4, and then it's going to equal r squared. Okay, so then we just need to find the radius. Well, again, we have the radius and the tangent, so that might help me, because so if I find the length of the line PN, the radius I've drawn, that will be the radius, right? The length of the radius. Well, I know the point N. To find the distance, I need to find the point P. However, I already know the two equations. I know the equation of the tangent and the radius already. I've worked that in part A. I can then equate them to find the point P. So y is minus 3x plus 25. That's what I worked out. And y is a third x. I can then, if I call that equation 1, equation 2, I can then equate them again, because that's the radius and the tangent intersecting at the point. To find that point, I can equate them. So I can substitute, say, 1. Now I'm going to substitute the second equation into the first, to then get that y, which is a third x, then is minus 3x plus 25. Well then, if I add the 3x, 3 add a third, gets to be 10 over 3x equals 25. Therefore x, and if I divide 25 by 10 over 3, I get x is 15 over 2. Therefore, to find the y value, well, I can substitute x into either equation here. Let's substitute it into this one because it's a lot simpler. Well, then y be a third of that, right? A third times 15 over 2 would get me that it's equal to 5 over 2. Therefore, the point P, the intersection point, was x is 15 over 2, y is 5 over 2. So I can fill that in. So P's there. Cool. Well, now I know the points P and N, so I can find the distance Pn, and that give me the radius. Well, Pn then, the distance Pn, again, that's going to be changing x between P and N. Well, let's take x then here. So 15 over 2. Take away 7. All squared. Then we add the change in y, so that was 5 over 2, wasn't it? At P, sorry. Yeah, 5 over 2. Take away 4. The y value at N. All squared. And then that will get me, if I put that in the calculator, root 10 over 2. Okay. I believe that I'll put that in right. Yes. So then that's the radius then. So therefore r, the radius is root 10 over 2. However, I can substitute that in, but I need r squared. So r squared is root 10 over that all squared. And that will get me 5 over 2. Okay. Therefore, the equation then is going to be x minus, what was it? X minus 7 all squared, add y take away 4 all squared is equal to 5 over 2. There's my equation of the circle. Cool. Okay, not too bad so far. Then it says the line with equation y is a third x plus k is also a tangent to C. Find the value of k. So what that, well, okay, okay. So you, I mean, you might think perhaps at that point substitute the equation, that equation in, to the equation of the circle, because we did just find the equation, to perhaps find k. I don't think that will go too bad. It will take a bit long, but you might be able to do that. But what you can realise in this particular instance, instead of going through all that for only 3 marks of that substitution algebra grind, realise that, well, actually, it's this other tangent has the same gradient, so it has to match this line's steepness. The only other way, if we do that and touch the circle, is going to be roughly like there, right? It's not exactly matching. There we are. It's going to be there. So it's going to be the same gradient. It's going to meet there instead. Okay. And because it has the same gradient, that means the radius is going to have the same gradient as well. That we worked out before. So we just have to extend that radius and it'd be the same equation of the radius we worked out. Okay. Because then that would be perpendicular. And because the gradient of the two tangents are the same, which is a third there, that means the radius's gradient must be the same. So it must be the same radius. Okay, that allows us to cut down a lot of working by using that same radius of the equation. Well, okay then. So as we just discussed, the radius indeed continues to this point here. We want to find that point there. Okay, so how could we work that out? Well, again, you could perhaps substitute the equation of the radius that we worked out into because it intersects a circle. You could perhaps do that again, use a normal substitution method. But for 3 marks, let's see another way we could find that point. Because if we find the point here, then we know a point on the line here to substitute to find k. Well, actually, it's if we consider it as a diameter, really, between these 2 points and P, remember we know what P is. Well, again, N would be the midpoint, right? So if we were to construct our between C, no, between let's call this point here M. Okay, so from this M here, which is the intersection with the other tangent here, which we're interested in, M here, and then to the point N, which is the intersection with the other tangent. Well, the midpoint, because this is a diameter then, the midpoint is, again, the centre. And this goes back to what we looked at with kind of like chords and perpendicular bisectors, which we looked at earlier on in the chapter, that the midpoint of a chord, well, no, the midpoint of a diameter is the centre. But here we know the centre is 7, 4. And we know well, it's P actually, which we worked out as well, 15 over 2, 5 over 2 in the last question, right? Well, we can work out this point, xy, can't we? That's just, if we consider the midpoint formula, we can work that out. So let's work out the midpoint, because it has to be the centre then. So if we do the midpoint between M and P, if we add the x values, x was 15 over 2 over 2, and then y add 5 over 2 over 2. Obviously xy had to just give us a general coordinate because that's what I want to work out. Okay, but I know that has to equal the centre, the midpoint of that line, because it's diameter, which is 7, 4. Then I can again equate those two coordinates together. So the x parts together, firstly, x plus 15 over 2 over 2 equals 7. Therefore, x plus 15 over 2 equals 14. So then x, if I subtract 15 over 2 to both sides, I then get 13 over 2. Okay, and then likewise for the y part, y add 5 over 2 over 2 equals 4, there and there. Therefore, y plus 5 over 2 equals 8. So then y is 8 take away 5 over 2 to get me 11 over 2. There we are then. So that coordinate at the other tangent intersection, M here, is 13 over 2, 11 over 2. So then we can add that to our diagram. Up here. So here, that point there, intersection with the tangent, or not the tangent, the diameter or the radius or whatever, with that point is 13 over 2, 11 over 2. Well, now I know a point on the line, and I know the line is this. I could substitute that point into the line. Hang on. So I'm going to sub 13 over 2, 11 over 2 into y is a third x plus k, right? Yes. So then I therefore get that y be 11 over 2 equals a third of x, which is 13 over 2, add k. Then 11 over 2 equals, well, a third times 13 over 2 gets me 13 over 6 equals plus k. Therefore, if we subtract 13 over 6 to both sides, I get k is 10 over 3. Cool, there we are. There we are. So, yes, that's that question now. So, yes, so that is, yeah, so that mostly right, mostly the same ideas that we just learned here. But here you just have to recognise that because the gradient is the same, we get the radius will continue. So it's the same line, which allows me to then consider what the point is, and I can use the midpoint there. Okay, so I don't need to use the substitution method to try and get a nasty quadratic, expand brackets. It'll take longer to get 3 marks, but you could do, but there we are. That's more elegant. I think a better solution there. So yeah, so that is generally a method, right? If you've got this sort of tangent problem, it's a good idea to try and see if you can solve it reasonably quickly before you jump into trying substituting stuff out, because it might take a bit longer to expand stuff and all that. But yeah, so that's that's tangents and chords and perpendicular bisectors. So that's it for this video. So I'll see you next time.